So now in this video we're going to make another circuit with the LM358. It's going to be very similar to the non-inverting comparator we made in the last video, but in this video we're going to make an inverting comparator. So basically we'll just look at the difference of that. We have to power the integrated circuit. We'll see there's the positive supply to VCC, negative supply called ground to ground. We're going to just use a single supply that has a positive and negative. It doesn't have a negative voltage in relationship to ground. Ground is the negative voltage. So in any case, we're just going to use this op amp. It's a dual op amp. There's two op amps on this integrated circuit. One over there, one over there. This is the only one we're going to do. Output on top, inverting input below it, and non-inverting input below that. So here it is on the board. We got the little divot on top there, the positive supply to pin number 8 as we saw before, and pin number 4, the negative side of the supply, ground right there since it's a single supply. And we have a trim pot here. So the purpose of this is the signal. So our signal voltage is going to the inverting input. When it comes to the output, it looks more like the non-inverting input. So we'll look at that later. But in any case, this is what's going to make it an inverting comparator, is that our signal is going to the inverting input. Now we make a fixed resistor voltage divider right here. They're equal value, so we'll get half of the power supply right there, 5 volts. We'll end up with about 2.5 volts there. Remember, these inputs just look at voltage. They don't let current go through or anything, so they don't throw off the voltage. One to the positive supply, 10,000 ohm resistor, 10K. The other to the negative supply. This one's just facing the other way. That's why the colors don't line up. But in any case, we have a reference voltage at 2.5 volts. When the trim pot right here, it's above 2.5 volts, is closer to the positive rail, we'll have a low output. So higher input than the reference voltage, and we will have a low output. A lower voltage than the reference voltage will have a high output. So now I hooked up the oscilloscope. We'll look at that coming up. I'll turn the output of this power supply on right there. So now we got 5 volts. Let's put that on current. No current right now. We are just going to take voltage measurements. There's no load at the moment. So right now it is 0 volts right there. That's what we expect because the trim pot is higher. The voltage is higher than what we set with our fixed value resistors. We can look at those quick. There we got 2.5 volts at the non-inverting input right there, and the inverting input we have a higher voltage right there, and so the output is low as we said before. Now we will turn the trim pot lower than halfway, doesn't matter where, anywhere lower right there, and there you can see the output went up right there. So that means that in relationship to our reference voltage there, 2.5 volts, since the output is high, that means our inverting input is lower than our reference voltage right there. So in any case, that's what inverting means. The signal is either higher or lower than the reference voltage in relationship to the output. And finally, I wired up a couple LEDs to the output. The red LED is lit because the output is high right now, going to long lead the anode, short lead the cathode, going to ground, even though the signal voltage here is down lower. If I go up higher, closer to the positive supply, now you can see the blue LED lights up. You know the output is low. We got positive there to the long lead the anode, short lead the cathode to a 1 kilo ohm resistor, higher value resistor because blue LEDs get brighter. But in case, it's connecting to ground as good as it can. It doesn't make a perfect connection to 5 volts or 0 volts. It does better with 0 volts, especially if there's no load. But it comes close. So, hope you enjoyed. Make sure you check out the links down below. I could use any donations that you can provide. I'll put those on top. But just watching videos helps a ton. So thanks for that. I'll see you in the next video.